Hello, I'm Ethan. All right, this is our problem statement. It is parallel parking can be a challenge, especially for older cars without modern sensors. To address this, our design assists users through the process of providing visual and auditory feedback to ensure stress-free parking. So this is in like aftermarket target. It's for cars that might be older, don't have these advanced sensors or anything like that. And kind of the audience that we're targeting for this are people who are either new to driving or don't have a lot of money for a newer car, so have to buy an older or used model, or people who just want safety features on their car. So this helps with parallel parking, or if you're parking in a parking garage, you want those backup sensors and those blind spot sensors to ensure maximum safety for this.
All right. My name's James. I'm gonna go ahead and give you a demo. So first off, we have front, back, and left and right sensors to help you on all sides. We have a main unit right here. Ethan's holding to help you show. So with the front sensor, we'll immediately get into it. They give you a distance readout. So as you can see, they each have a corresponding screen. So the top screen's for the front. As you get too close, your light changes. If you're far enough away, it just says far. And then as you get closer, it starts giving you an actual distance readout. That way you know exactly how close you get. Once you get to way too close, light goes red, you get a buzzer, it tells you, hey, you're too close. Same deal in the back for backing up. You start to get too close here, starts to go green, starts to update the distance, and then you get close enough and it starts buzzing. You can see here it's changing as you get too close. Finally, we also have left and right sensors. These come with no buzzer, no readout. The main point is just to let you know, see top screen here, and on the other side as well, get a light, just let you know, hey, you're getting close. The reason this doesn't have a buzzer is anytime a car passes you on the highway, you get it. Anytime you merge, you get it. So the idea is just to let you know you're getting close, give you a visible sign that you're starting to get well within range of another vehicle.
Hi, I'm Brendan, and here is the code behind this project. So over here we have the transmitter. We set up the pins that the ultrasonic sensors are connected to, and then transmit the data received by each respective sensor. You can see that here on our code flowchart. We read those ultrasonic sensor values and transmit the distances. Once those distances are acquired on the receiver, we have all the pins defined, and we set up some variables that will come into play later. We get those distances and go through a series of if statements that says if the distance on the front is less than 10, red light. If it's less than 50, green light. If it's neither of those, blue. Same exact thing on the back. And then if either of them are less than 10, we will sound the active buzzer. And then for the left and the right, if either the distances are less than 15, their respective LEDs will turn on. And then here is the setup for the LCD screen. And one of those variables we mentioned earlier is LCD delay. This just means that the LCD screen will only print a new value every 500 milliseconds to prevent it switching fast and distracting the driver. If the distance is greater than that set distance threshold, we will print far. Otherwise, we'll print the actual recorded values. And this can be seen over on our code flowchart, where for the front and back, if the distance is within the initial threshold, it'll check if it's within the final threshold. If it is, it'll do a red LED and activate the buzzer. Otherwise, it will be green and the buzzer will be off. If it's not within any distance threshold, the LED will be blue and the buzzer is off. There's the same thing for the back. And then for the left and the right, if it's within the distance threshold, it will turn on the corresponding LED. If it's not, it will turn the LED off.
All right, hi guys, I'm Charlie, and I'm gonna walk you through a bit of the hardware that we got. So if you wanna take a look here, we have a circuit diagram of our transmitter. Here we have 4 ultrasonic sensors, each of which is housed in a different housing across the car. And that all runs to an Arduino Uno, which we have located up here in the front of the car. Next to that Uno, we have the NRF24L01 transceiver that will send our data to our main unit, which is the receiver over here. Just take a closer look. Here's our receiver diagram. This is built off an Arduino Mega. So we have our 2 RGB lights up here, 2 LED lights, our blind spot indicators, our active buzzer, our transceiver once again, and then our 2 LCD outputs. To kind of take a look inside, I know it's a little easier to see on this diagram, but that's just to take a look. It's all housed within here, so completely wireless transmission. The idea with this is it'll go in the center console of a car. And these units on the side, right now we only have 1 point of wireless transmission, but the idea is in a final prototype, we could have each of these housings transmitting separately. That way we could have an attachment that goes on a car, really anywhere you want to locate it, and just have a good final polished solution. So that's our presentation. Thanks for watching.